So hello everyone. So welcome to this last session of this module. Okay. This would be the last session. We are going to solve 4 problems. Okay. This would be a little long session. So here in this session we are going to solve the sum of the integrals. Okay. I have told you, right. Here they won't be giving any f of x or f of s values. After that, for that we need to find the Fourier transform, again inverse transform. No, for that in this kind of problems they would be giving the integrals itself. First thing what we need to do in these kind of problems is we need to identify whether it is a Fourier sine transform or cosine transform, and for this integral they would be giving some certain values, and we need to be knowing where to use these values. Okay, so the first question given here is we need to solve for the integral 0 to infinity f of theta cos alpha theta into d theta, and it is given as it is 1 minus alpha when alpha value lies between 0 to 1, and it is 0 when alpha is strictly greater than 1. Okay, and here also we need to evaluate these two cases, that is 0 to infinity 1 minus cos x by x square into dx, and the other case is 0 to infinity sine square t by t square into dt. Okay, so first thing we need to identify this equation. By seeing this equation we can see that the interval is from 0 to infinity, and here the function we have is cos. So here we can guess that in this integral is an Fourier cosine transform, right, since we have cos. But the formula for Fourier cosine transform is f of x cos sx into dx, right, 0 to infinity. Here what are the changes we observe between this equation and this equation? If you observe carefully, in place of theta, in place of x we have theta, and in place of s here we have alpha, right? So the same thing we are going to write it as solution itself. Here first write that by comparing these here we can see that the first thing that we need to know that this is an Fourier cosine transform, right? By comparing these two equations here, write the values which are equal, that is here the x equal to theta and s is equal to alpha. So now first thing we need to do is we need to use the inverse Fourier cosine transform. Since this integral is of the form Fourier cosine transform, the first step we need to use is we need to use the inverse Fourier cosine transform, that is fc inverse of theta, right? Here in place of s, fc of theta, and it is given as 2 by pi into 0 to infinity f of theta, right? So it is not fc of s, it is fc of theta now, f of theta into cos alpha theta, and the parameter is from d alpha because the value of s is equal to alpha, right? So here instead, generally we had for inverse Fourier cosine transform it has ds, right? So here the parameter s is equal to alpha, so we need to write it as d alpha. Okay, and that is again equal to f of theta. It is not equal to f of x because in place of x we have theta here, right? Okay, so now write it as f of theta is equal to 2 by pi, and here the limits are from 0 to 1 and 1 to infinity. We are not going to write that 1 to infinity. I am just splitting the interval, that is from 0 to infinity. So 1 is from 0 to 1. Here it's given as 1 minus alpha, and it is 0 when alpha is greater than 1, so I am not writing that. So here the value of f of theta given here is 1 minus alpha in the question, cos alpha theta, and the parameter is d alpha. Okay, so now for this we are going to use the solve this integral now. Okay, 2 by pi into the we are going to use the Bernoulli's rule now. Okay, so first function as it is, here we need to be very careful by solving the problem, since the parameter here is not dx, right, it is d alpha. In such a way we are going to solve this now. Okay, into the second function, that is cos alpha theta. The derivation of cos is sine alpha theta divided by, now the parameter is not the parameter is d alpha, right? So now we need to see the coefficient of alpha, not theta. Okay, in order to write the denominator, the coefficient of alpha is theta right here, so we are going to write it as sin alpha theta by theta, okay, minus the differentiation remains the same again. Differentiation of 1 is 0 and alpha here it is not a constant term, so we need to consider it as a variable, okay. So the differentiation of any variable is minus alpha is minus 1 into again the integration of this function minus cos alpha theta divided by, since the parameter is alpha, we need to take the coefficient of alpha, that is theta, into the integral is from 0 to 1. Now apply the limits, that is 1 minus alpha, right? So the parameter again is alpha, so wherever there is alpha in this equation, substitute the limits there only, okay. So 1 minus alpha, replace alpha by the upper limit 1, so it is 1 minus 1 into sine alpha is 1, right? So it is sine theta by theta minus into minus plus, plus into minus, minus again cos theta by theta square, right, minus the lower limit, that is 1 minus 0, 1 minus alpha is 0, 1 minus 0 is 1, so sine 1 into sine 0, right, alpha is 0, so 0 into anything is 0, divided by theta minus cos 0, again minus into minus plus, plus into minus, minus by theta square. So now by solving we get it as 2 by pi into, so 1 minus 1 is 0, so this whole term is 0, sine 0 is 0 again, so the remaining terms are minus cos theta by theta square, minus into minus is plus cos 0 by theta square. So now f of theta is equal to, we can take 1 by theta square common outside, okay. So this would be 2 by pi theta square into cos 0, let's write the positive term first, cos 0 is 1, right, minus the remaining term here is cos theta. So this is your required f of theta. So now first, in this case we have used first the inverse Fourier cosine transform, right. So now we are going to apply the Fourier cosine transform, that is the given question. In the given question this is given, right, this condition. Here it is given that f of theta into cos alpha theta d theta. Here f of theta is there, that is we have found the f of theta using the inverse Fourier cosine transform, right, this f of theta. The same thing we need to do here, that is we need to replace the value of f of theta in this equation and solve the rest of the problem, okay. This is simple. Now let's solve it. That is fc of alpha. Generally we would be having fc of s, right, but we know that here s is equal to alpha, parameter s is equal to alpha, so it is fc of alpha into is equal to 0 to infinity f of theta. The question itself we are going to write it again, cos alpha theta d theta is equal to, it is 1 minus alpha when alpha and 0 when alpha is greater than 1, okay. So now substitute the value of f of theta which we have solved here, that is 2 by pi theta square into 1 minus cos theta into cos alpha theta d theta, okay. So now the first thing we need to evaluate here is 1 minus cos x by s square. Yeah, I forgot to tell you that, we are applying this Fourier cosine transform to evaluate, okay. First thing we have found the f of theta, right, so we are applying this applying the Fourier cosine transform and substituting here f of theta because we need to evaluate the cases, okay. For that we are doing this. So the first thing, evaluation case is 1 minus cos x by x square, right. So here we have 1 minus cos theta and here we have theta square. The rest of the terms, right, that is 2 by pi and cos alpha theta, that terms are now in our path, that is we need to separate them. So the first thing we can do here is we can take this 2 by pi common outside, unity 1 minus cos theta by theta square cos alpha theta d theta is equal to the same thing, that is this condition itself. So now in the next step what we are going to do is we need to put the value of alpha is equal to 0 so that we eliminate this term, because we need only this term, right? Like this 1 minus cos into something divided by something square, right? We have theta here. If we are at last step we need to replace the value of theta by x, right? So we don't need this. In order to eliminate this, put the value of alpha is equal to 0, so this gets eliminated. Okay, yeah. So if we put the value of alpha is equal to 0 in this equation, 1 minus alpha is there, right? So in this side it is 1 minus alpha. It is the integral is from 0 to infinity, and we know that it is splitted from 0 to 1 and 1 to infinity, and from 1 to infinity the value is 0, so we are not going to write the second case now, 1 minus alpha. So now when we put the value of alpha is equal to 0, so now this would be 1 minus 0, right? So now let's write the remaining equation, that is 2 by pi 0 to infinity, put alpha is equal to 0 here, okay, 1 minus cos theta by theta square into d theta. Cos alpha theta would be eliminated, right? That is equal to 1 minus alpha, right? So 1 minus alpha means 1 minus 0. Therefore 2 by pi 0 to infinity 1 minus cos theta by theta square d theta is equal to 1. So now bring this 2 by pi to other side, that is 0 to infinity 1 minus cos theta by theta square d theta is equal to, there is 1, right? So if we bring this to other side it would be pi by 2. So now again we have nearly completed the problem. Here now we need to replace the value of theta by x, okay, so that we will get our first case, that is 1 minus cos, wherever theta is there replace it by x square dx is equal to pi by 2. See, we have evaluated one case. So now the one more is there, that is sin square t by t square dt, right? Yeah, so now we'll do that. So now we need to find the second case, that is sin square t by t square into dt, okay. So now here, in order to find this, right, we need to use the above equation, that is the above first case that we have solved. By using that equation, let's name that equation as 1. So using this above equation 1, we need to solve for the second case, that is, what is the first equation? 0 to infinity 1 minus cos x by x square dx is equal to pi by 2. So we have an identity for 1 minus cos x, right? Yeah, the 1 minus cos x can be written as 2 sin square x by 2, right? Okay, so now we are going to write that itself. So I'll write it here, since 1 minus cos x is equal to 2 sin square x by 2. Okay, so now in this equation, so now equation 1 would be looking like 0 to infinity 1 minus cos x is replaced by 2 sin square x by 2 divided by x square dx is equal to pi by 2, right? So now again the same thing here, x by 2, take x by 2 is equal to t, okay. So now bring this 2 to other side, so x is equal to 2t, differentiate on both sides, therefore dx is equal to 2 dt, right? So now replace these values in this equation, so that is 0 to infinity 2 sin square x by 2 is equal to t divided by x square, so x value is 2t, so it is 2t the whole square, and dx is equal to 2 dt, right? That is equal to pi by 2. So this is 0 to infinity, 2 into 2 is 4 sin square t divided by 4t square dt is equal to pi by 2. So now if we cancel this 4 and 4, so we left the terms left out are sin square t by t square into dt is equal to pi by 2. So that's all we need to solve, right? We need to solve this only, right? So now see, by using the first equation we have solved this case also, right? So in this case we need to solve these particular integrals when they have given the integrals. Okay, so we have 3 more problems. We'll solve it fast. Okay, so we can complete in this session itself, right? Okay, so now we'll solve the second question. Okay, so this is your second question, that is we need to solve for the integral 0 to infinity f of x cos alpha x into dx is equal to e to the power minus a alpha. Again we need to see the equation. So here we can see that this is again of the form cos, right? So Fourier cosine transform, right? Okay, so now solution, Fourier cosine transform, right? That is fc of alpha, right? Here the parameter here is s, right? So s is equal to alpha. So fc of alpha is given as 0 to infinity f of x cos alpha x dx is equal to f of x e to the power minus a into alpha, right? This is the given condition here. So therefore we can even write it as fc of alpha is equal to e to the power minus a alpha. Okay, if we write fc of alpha is equal to e to the power minus a alpha, so now by using the inverse Fourier cosine transform we need to substitute directly the value of fc of alpha is equal to e to the power minus a alpha. Okay, yeah, so now we are going to use the inverse Fourier cosine transform. Yeah, so this is the formula for inverse Fourier cosine transform here. 2 by pi 0 to infinity fc of alpha, right? The parameter is not s here, alpha. So cos into alpha x into ds, it would be ds, right? So here the parameter is alpha, s is equal to alpha. I'll write it here. So it would be d alpha. Okay, yeah, so now we'll substitute that. So this is equal to f of x, right? Yeah, 2 by pi. So this is not f of x. Okay, here this function is an integral. This integral is equal to this. This is not f of x. Please don't confuse it. Okay, this here is not equal to f of x. Okay, yeah, 0 to infinity the fc of alpha is equal to e to the power minus a into alpha, right? Cos alpha x into d alpha. So again we are going to use the formula e to the power ax cos bx plus c. Okay, so here we need to remember that the parameter is alpha, not x. In the same way we are going to write the formula also. So now let's rearrange these terms so that you people won't get confused. That is e to the power minus ax is there, right? Wherever x is there, replace it by alpha. That is e to the power minus a alpha cos x alpha. I am writing it as x alpha so you people won't get confused. D alpha. So now let's apply the formula. That is f of x is equal to 2 by pi into e to the power a value here is minus a alpha divided by, so value is minus a, right? So minus a the whole square is equal to a square plus x, the value of b, this is x equal to b here. Okay, that's why I have interchanged this, because if you put the alpha is equal to b the whole sum would be wrong. So in order to understand this I have just interchanged this. So here the value of x is equal to b. Okay, so it is a square plus x square into minus a cos bx, right? Alpha x plus minus a cos x alpha, right? So yeah, b here b is equal to x. Okay, x sin x alpha. Okay, and the limits are from 0 to infinity. So now bring this a square by x square outside, so that is 2 by pi into a square plus x square into, take this e power minus a alpha common for these two terms, into minus a cos x alpha plus x sin x alpha, and the limits are from 0 to infinity. So now apply the limits. 2 by pi into a square plus x square into, now multiply these terms, that is minus a power minus a into alpha, right? In place of since the parameter is alpha, wherever alpha is there, replace it by the upper limit infinity cos x into infinity plus x, I am just multiplying these two terms, x into e power minus a, alpha is infinity, sin x into infinity minus the lower limit, that is minus a e power 0, right? Alpha is 0, so this into this 0 into anything is 0, so e power 0 cos 0 plus x e power 0 sin 0. So we can cancel some of the terms, that is this sin 0 equal to 0, right? So the remaining terms here are 2 by pi a square plus x square into minus a e to the power infinity into anything is again infinity, cos infinity, right? Again infinity into anything is infinity, plus x e power again minus infinity sin infinity plus a, right? E power 0 is 1 and cos 0 is also 1, minus into minus plus, so a will remain. So again we can cancel these two terms since e power minus infinity is equal to 0. So now the remaining final answer which we get is 2 into a divided by pi into a square plus x square. So this is your final answer. Okay. So now we'll solve one more problem. So this is your next problem, that is integral from 0 to infinity f of x cos lambda x dx is equal to e to the power minus lambda. So this is similar to the problem which we have solved before. This is similar to the problem which we have solved before, okay? So here the thing is that now till now we had alpha as the parameter, right? Here in place of x, in place of s we have lambda, okay? So again the same thing here, identified cos is there, right? So it is Fourier cosine transform, and the Fourier cosine transform is given by fc of, so the parameter here is lambda, right? So it is equal to 0 to infinity f of x cos lambda x into dx is equal to e to the power minus lambda. So we can write it as fc of lambda is equal to e to the power minus lambda, right? So now again use the inverse Fourier cosine transform to solve this, okay? So the inverse Fourier cosine transform in this question it is given as 2 by pi 0 to infinity fc of lambda cos lambda x into the parameter here is lambda, right? So d lambda, okay? So this can be replaced by f of x 2 by pi 0 to infinity, the value of fc of lambda is equal to e to the power minus lambda cos lambda x into d lambda, okay? So here again we need to use the e power ax cos bx plus c formula. So if we substitute the formula here, we get it as 2 by pi into e to the power ax, right? So here the x is replaced by lambda here, so the value of a here is minus 1, so minus lambda divided by a is minus 1 the whole square equal to 1 plus the value of b here is x, okay? The value of b is equal to x, so the value of here it is x square minus 1 into cos x lambda, value of b is x, right? Plus x sin x lambda into the limits are from lambda, okay? Lambda limits are from 0 to infinity. So now the same thing as previous problem we are going to solve it. Take this 1 plus x square common outside and minus e to the power minus lambda cos x lambda plus x e to the power minus lambda. I am just multiplying e to the power minus lambda sin x lambda. The limits are from 0 to infinity. So now again apply the limits 2 by pi into 1 plus x square minus e to the power, wherever lambda is there, replace it by upper limit infinity cos x into infinity plus x e to the power minus infinity sin x into infinity minus the lower limit, that is minus e to the power minus 0, right? Cos 0 plus x e to the power minus 0 sin 0. So here we can cancel. E to the power minus infinity is equal to 0, right? So these two terms also will become 0, along with sin 0 is 0, so this term is also 0. So the left out term here is 2 by pi into 1 plus x square into minus into minus is plus, and e to the power minus 0, so this also can be written as 1 by e to the power 0, and you know that e to the power 0 is 1, so 1 by 1 equal to 1, so this is equal to 1, and also cos 0 is 1. 1 into 1 is 1, minus into minus is plus, so 1 would remain. So the final answer which we get is 2 by pi into 1 plus x square. Okay, yeah, so this is your answer. So here nothing much. In the last problem we had 2a divided by a square plus x square, right? So in this problem the value of a, if we replace it by 1, we get this as your answer. Okay, so now we have one more problem left, so now we'll solve that. So yeah, this is your last question of this model. Okay, that is, here we can see that in this integral sine is there, right? So here we know that this corresponds to an Fourier sine transform. Okay, and it is given as fs of, and the parameter here is alpha, is equal to 0 to infinity f of x sine alpha x into dx, and for that we have these three values. Okay, so now for this we are going to use the inverse formula. Whenever we have more than 3 values for this integral, for that case only we are going to use this inverse formula. Okay, so now use the inverse Fourier sine transform formula. Yeah, so the formula is given as 2 by pi into 0 to infinity fs of alpha sine alpha x into, the parameter here is alpha, right? So d alpha, and this can be replaced by f of x. So now here the same thing, the limit is from 0 to infinity, right? And we have the given conditions here. So in that case we need to split the limits from 0 to 1, 1 to 2, and 2 to infinity. Okay, that is 0 to 1, the value of fs alpha is given as 1. Okay, 1 sine alpha s x into d alpha, plus from 1 to 2 the value of Fourier cosine transform is given as 2 sine alpha x into d alpha, plus from 2 to infinity the value is 0, right? It is given as 0, so this term we can cancel. So the remaining terms left out are 2 by pi into 1 and 2, if we will take it outside. Okay, so if we take 1 outside, we can directly use the integral and solve it. That is integral of sine alpha x. So integral of sine is minus cos, right? So minus cos alpha x, and the parameter is alpha, so we need to divide the coefficient of alpha, not x. So the coefficient of alpha here is x. Okay, and the limits are from 0 to 1, plus take 2 outside, into, again the integration of sine is minus cos alpha x, and the coefficient of alpha is x, and the limits are from 1 to 2. So in this way we are going to solve this now. 2 by pi into, apply the limits here, minus cos, the upper limit is 1, so this would be, now in place of alpha, we know the parameter is alpha, so in place of alpha substitute 1, so it is minus cos x by x plus cos 0. How it is plus? Because here we have minus, right? So minus of, I'll write it, minus of minus cos 0 by x, plus the second integral, that is 2 into, the upper limit is minus cos 2x, right, by x, minus of minus cos x by x. So now 2 by pi into, so here we can see that 1 by x is common, right? So we can take that 1 by x common outside in these two terms, and the remaining terms left out are minus into minus is plus, right? So this plus positive term, I'll write it first, that is cos 0 minus cos x plus, so here again 1 by x is common, so I'll bring that outside here, 1 by x, and I'm going to multiply 2 to the numerators, that is 2 cos x. First I'll write the positive term, minus into minus is plus, so I'll write it as plus 2 cos x minus 2 cos 2x. Okay, yeah, f of x is equal to, here again 1 by x and 1 by x and are common for these two terms. These two terms 1 by x are common, right? So we can take that 1 by x together outside, that is 2 by pi x into, the remaining terms are cos 0 is 1 minus cos x, and here plus 2 cos x minus 2 cos 2x. So we can combine these two terms, minus cos x and plus 2 cos x, that is equal to f of x is equal to 2 by pi x into 1 minus 1 plus 2 is equal to plus 1, 1 plus cos x minus 2 cos 2x. So this is your required answer for this solution. Okay, yeah, so this completes this module, that is the third module which I have covered till now. Okay, so in order to, in the next session we are going to start with the new module, that is again a interesting module and a very mathematical module, and many calculations are there in that module, and it's personally my favorite module as well. Okay, so yeah, I'm going to teach that module very nicely for you all. So this completes this module. So if you have any doubts, I have told it again and again, you can comment it down. We have provided all the questions for you, the notes, everything is given. Please, if you have time, you can see the description as well. And in order, if you think that I'm going fast, so after my completion of my all the solutions, you can pause it and you can refer that and you can write it down. Okay, yeah, so that's all for this session. We have covered, I guess, 6 sessions for this module. Okay, so we have left out with the 2 concepts. I'm not sure that in this module we have left out 2 concepts. I'm not sure that whether those concepts are there or not. Okay, yeah, so that's all. Thank you.